and keeps track of the resources that have been opened by that process, files, registry keys, and so on. But it's actually threads that execute the code that's in that process address space. It's the unit of scheduling in Windows, and most processes have more than one thread so that they can do things like service I/O while they're reacting to your input in the window. And just as a special case, there's a process called the system process, which you'll see in the process list, that hosts the threads for the system itself in kernel mode. Things like the memory manager worker threads and the general thread worker pool. Threads for device drivers are also hosted in that special process. To look at what threads are running inside a process, you need to go to the Threads tab of Process Explorer. So let's open Process Explorer Threads tab for this service host that's run away and see what's running. By default, it'll sort by CPU usage. And you can see that there's two threads in here that are both running with the CPU. One, actually let me let the symbols aren't downloading. One is in this general DLL here, ntdll.dll. We'll come back to that one in a second. But the second one here is in a started its life in a DLL called servicehog.dll. That sounds a little suspicious, doesn't it? Maybe the purpose of that DLL or that service is only to consume CPU, and it is, of course, that service's only purpose. I wrote it just for this. And it's consuming roughly 5% of the CPU just constantly. The start address that you're seeing here, where you see names like these here, ADVAPI, SV controller thread, Process Explorer is getting that from symbol information that Microsoft makes available on its public symbol servers. I'm not going to show you here, but you can go to the options dialog and configure Process Explorer to go pull those symbols down from the symbol server. And the instructions for how to do that are also in the debugging tools for help file, also in the debugging tools for help web page, and in the slides themselves that come here. Once you do that, you get helpful names that will show you function names inside of modules. But here, it's good enough just to know what module these things began its life in. Like, I know that servicehog.dll, I go to the service list here, I can see that servicehog, that DLL, shows up right here as the host for this particular service, the servicehog service, which, as if we didn't know, needlessly hogs CPU. That's the description that the programmer puts in there that you can see there. So we've got part of the problem solved in this case. It's that this servicehog service is causing the problem. On this machine that I had at home, what I ran into was that if you look at the start address there, it's ports.dll. And ports.dll is the multimedia DLL in Windows. It's another inbox component. So again, I was at a dead end. It's not that DLL probably that's at fault. It's probably something that it's calling into. So I needed to take an even deeper look. I needed to look at the stack of the thread to see if that gave me any clues. The stack of the thread shows you the function invocation history at the time you look at it. Because threads, when they execute code, are usually calling functions that are in different modules or in the same DLL that the programmer's divided the code into. And the way that the system knows how to get back to where the thread came from when it finishes a function is by putting the return address of that function on the stack. So if a thread call started in function 1, then called function 2, then called function 3, you would see function 1, function 2, and then function 3 on the stack, and that would show you that the system knows how to get back to function 1 when function 3 and function 2 finish. It's a per-thread region of memory in the process address space. And we can look at the thread stacks in Process Explorer by double-clicking on the thread that we're interested in. So let me take a look at, for this general one, the symbols have finally resolved here. This general one, this one consuming the most of the CPU, is inside this generic worker thread function. That's where it started its life, which is of no use to us. So let's go take a look at the stack. And what you want to do when you look at a stack is look for the plugins or the third-party components that are most likely to cause the problem. And if you go scanning through the stack here, and this of course takes getting some practice to get used to things, recognizing the inbox things from things that aren't inbox. And the first steps of this would just be to investigate. ntdll, that's an inbox component. That's part of the operating system. Kernel 32 there at the bottom is part of the operating system. And what I'm doing is working my way up like this because that's the thread started its life actually here and then called these functions one at a time. You can see that it called into service hog right there. And service hog is basically just sitting there consuming CPU when the thread stack was examined. So now we've identified the root cause of that second thread consuming CPU, which happened to be the same service. To get that service out of the way so that I get my system back, I'm going to just suspend that thread right there. And you can see that now my CPU usage dropped, and that remaining service hog thread, suspend it, and now it's dropped. So I've actually worked around the problem for the purposes of this presentation. And we can move on. But let's take a look at what I saw on the home system. I saw Sonic MP4demux.aux as the third-party DLL on that stack. OLE32 below it is a system DLL, kernel 32 and user 32 and NTDLL, our system DLLs above it. That Sonic MP4demux, third-party thing. So my question was, where did this come from and what is it doing? So I did a web search and I saw that Sonic is actually part of Ruxinovich, which is a maker of CD-ROM burning software and DVD burning software, which had been installed on this machine, came with the machine from the OEM. So I determined where and how this thing got loaded so I could figure out how to stop it from getting loaded, on the presumption that this would happen again. So what I did was ran Process Monitor, and I left for work in the morning, left Process Monitor running on the machine, so that when I came home, I could go look at the log and see what had started up that Ruxinovich, that Sonic MP4 DLL. To do that, there's a trick that you can use with Process Monitor, and that's to go to the, there's a couple of tricks you can use. One is to set a filter and select in the options here, destructive filtering. It's actually here, drop filtered events. And that will minimize the size of the log because Process Explorer won't keep track of the things that you are filtered out. But what I did in this case is I figured, hey, I can just save the log, save the information to a file on disk, because a file on disk is much less likely to run out of disk space than I am to run out of page file space, which is where Process Monitor normally stores its events. So you can do that here in this dialog here, select a backing file, and that will have Process Monitor log right to that file as it captures the events. And when I got home that day, believe it or not, 18 million events were in the log file as when I loaded it up. So Vista might be slow, but it does a whole lot for you. Let me load that log file in here. And I actually set a filter here and did the drop thing. So I was only capturing DLL host because I knew DLL host was loading that Sonic thing. This will just take a few seconds to default this stuff in. And what I'm going to come across is where the DLL host here does a reg query value of a particular key, and in the results, the search hit on this Sonic MP4 demultiplexer. If you look at the key that it hit, the value is friendly name. That's what that Sonic MP4 demultiplexer is. And when I looked at this rest of the key, well, class ID, that's where COM classes are stored. So this is a COM class. I did a web search actually on that CLS ID on the first few characters of it, 083863F, and found that that was the plugin for generating thumbnails for, what's it called? I can't remember the name of the type of DLL, but it's the type of DLL that loads in thumbnails. And what I found also when I found that hit in the web was that the subkey here, instance, is where the plugins are actually registered for the thumbnail generator. And so this class ID is actually the class ID for the Sonic MP4 demultiplexer filter. That's what they're called, filters. And so what I did was, instead of deleting this thing, I renamed it. I didn't want to uninstall Ruxinovich because we occasionally burn DVDs, but I figured I didn't need this thumbnail stuff that it was doing, especially when it's clogging up my system. So I simply renamed this key and waited a few days and the problem didn't show up again. So I worked around the problem simply by doing that. I didn't mention before we started that a bunch of these examples I've actually written up in blog posts. This is my most recent blog post, The Case of the Slow System, where I actually wrote this case up and documented this. And so some of these others are also written up in that way. So I recommend you go take a look at that. Our next